So our agenda today is to cover colorimetric versus shared appearance matching. The overall goal of any organization that produces prints is to satisfy the customer expectations. And in satisfying the customer expectations, it's very critical to understand whether or not the customer is expecting a colorimetric match or a shared visual appearance match. And we'll talk about the difference as we go through here. The beauty of this is it works with any print process on any substrates. Now, we'll talk about when you'll use a colorimetric match versus an appearance match. And we'll also focus on imagery and images. Although the same topic relates directly to brand colors, we're going to save that for a future webinar. So, as I talked about, our goal is to provide prints that meet customers' expectations. But why is it so difficult? A lot of reasons. Customers supply files in the wrong color spaces with mixed intents. Output devices print differently from one another. Devices change their color characteristics over time. And then you add multiple substrates into the mix, and you start holding your head going, do I really need to build a profile or build a G7 curve for every substrate? Really? So, for all these reasons, meeting customers' expectations when it comes to color is a challenge. So, we need to ask, what are our customers really wanting? And build a color strategy based on their needs. So let's first define what a colorimetric match is. A colorimetric match means that it's an absolute color match between how two devices, and they could be the same device or they could be different devices, how two devices render color. A colorimetric match is often used in a proofing scenario where you want your proofer to match whatever press condition you're printing to. And the more accurate you can get those two to match, the better. And it forms a contract that when the customer signs off on the proof, that the press will match the proof. This is a, shall we say, the legacy of all colorimetric matches is proofing. But when you start talking about outputting on digital presses and large format presses, there's a confusion between what a colorimetric match is versus what I'll call a shared visual appearance match. Shared visual appearance means that I'm taking advantage of all the color that my output devices have available to them. So if I've got 3 different devices on 3 different substrates, I want to have the same tonality and the same gray balance between these devices, but I don't necessarily want to dumb 2 of them down, or potentially all 3 of them down, to match them all to one another. So when we say a shared visual appearance, we're saying we're taking advantage of the range of color that my output device allows me to have, and take full advantage of the range of color that that device is capable of. And if I do have the same job that needs to be rendered on 3 different devices in a shared visual appearance mode, they will all share the same gray balance and tonality, but not necessarily match color. So as you can see, most companies that are involved in reproducing color require a combination of both of these strategies. You'll use color match in scenarios such as proofing, as well as when you have, let's say you have so much volume of this one type of work that you need 3 different devices to keep up with that volume. Well, you don't want to keep track of which customer file went to which one of these three devices. So that's another scenario where we would use a color match. In most other situations, my experience is that a shared appearance is what predominantly is used when we're talking about large format printing and digital presses. So the question comes up, why not just colorimetrically match everything? The reason we can't colorimetrically match everything is because of the laws of physics. Devices have color capabilities which are finite to that device condition, meaning the device and the substrate. And we can't make devices produce more color than they're capable of producing, which means if we start mixing and matching devices with different ranges of color, we have to essentially dumb everything down to the lowest common denominator or the smallest common gamut to make them all match one another, because we can't add color to a device that can't make it in the first place. So to give you an idea, I have some samples here. This is a three-dimensional graphic showing you the range of color of two devices. Device number one is a Canon Arizona large format inkjet printing device, and it has a very large gamut. Device number three that I'm showing here is a Canon ColorStream output device. I'm not picking on any manufacturer, just showing two Canon devices, and you can see that the range of color between these two devices is very different. So if I were to go with the shared appearance on these devices, and I had this brilliant sunset image, device on the left would be the Canon Arizona printer with the large gamut, and the vivid yellows and oranges are just shining through. Device number three on the right is the Canon ColorStream device, which, due to the substrate that was in the device and the range of color that that device is capable of, it has much less vividness or saturation in the color. But when I'm doing a shared appearance, I'm taking full advantage of each device's range of color, and so I have the same gray balance, the same tonality, and the same look, the same appearance. Whereas if I decided that no, I really want a colorimetric match, you can see instantly that I have to take away substantial color from my Arizona, and I even have to take away some color from the ColorStream to make them common, to allow the color spaces to be in common with one another. And when you look at the difference side by side, it's pretty dramatic. And there's been numerous studies that show that people like vivid color. It might not even be accurate. If it's more vivid, people like it. And so the more we can take advantage of the gamut that our output devices are capable of producing, the more satisfied our customers will be in most scenarios. So when we get back and we talk about matching colorimetrically, this graphic shows the common color that's available between these two devices, and it really limits the range of color that you can actually print. So you might be asking, well, when would I use a colorimetric match besides proofing? Well, typically, like the scenario I shared with you at the beginning of the presentation, when you have multiple devices on the same substrate that are all doing overflow work for one another, in this scenario, you want these, in my scenario here, these three HP 360s to all match one another. Because if you make a 9-panel tiled job and the installer screws up tile number 9 and they call you back up to reprint tile number 9, you don't want to have to look in your records to see which HP 360 printed that tile job, because we can only print that job on that same HP, because if we print it on one of the other HPs, it might not match. A lot of companies are in this scenario today, and it's a nightmare scenario that you don't want to be in. But if you've got all 360s matching one another, then you don't have to worry about which job this tile job printed on, and you can print it on any of your 360s, and you're ready to go. And this becomes so critical when you start talking about routine maintenance that can take a printer offline for a day or two. If your jobs are contingent on that one printer and it's offline, and you've got the same make and model sitting next to it, but because you didn't implement color management, you can't take advantage of that, that's costing you time and money. And so in this way, by making these HPs match one another, we can share the load and share the volume. Now, which HP 360 do we choose to match the other two to? Do we choose one 360 to match the other two, or do we choose something else? Well, definitely you don't want to match them to one another, but you want to match them to a reference. And the reason you want to match them to a reference condition is that, let's say HP stops making the 360 in a few years, and yet you've got all this legacy of work that's coming in, and they want you to produce the same work as you produced on the 360, but you can't get a 360 anymore. So now you've got an HP, I'm inventing a number here now, we'll say a 36,000. And ideally, if that 36,000 matches that reference, that you can start rolling in B36,000s and continue to do the same work you've always done, because you're hitting the same reference that you've always hit. So ideally, you want to use an industry reference condition, and I'll talk more about what these choices are in a few minutes. But choosing a reference is critical when you're doing a colorimetric match. And of course, we have to show an example of a colorimetric match. In this scenario, I've got my HP 360s all matching to a Grackle condition. Grackle is a industry reference condition, which is very available today. Many people know about Grackle. It defines the range of color that an offset press on a #1 paper stock is capable of doing. And it can give you some good results. And ideally, you'll have an intelligent color server in the background doing these color conversions so that you get the colorimetric results that you're looking for, no matter the device you're printing on. Let's go back and talk more about our reference printing condition. And I like to refer to this as a stake in the ground. And ideally, the reference condition should be a G7 based condition. And when we say G7, G7 is a methodology that defines the gray balance and tonality for how different output devices on any substrate image color. And by providing this G7 methodology, we get a shared visual appearance no matter the substrate, no matter the process, because it shares the gray balance, and it in fact adapts the gray balance based on the color of the paper. So even if you have a blue paper and a yellow paper, when you apply G7 to it, visually when you put them side by side, the grays will visually match. Now, the problem when we talk about many digital devices and large format devices is that we don't want to necessarily build G7 curves. Ideally, we want to build an ICC profile that defines the gamut of my output condition, and then we do a color conversion based on an ICC profile reference condition to make my output device match our stake in the ground. So this stake in the ground is really important for your strategy, whether you're talking about matching colorimetrically or shared appearance. This stake in the ground is critical. So then the question is, which stake? Well, ideally, we want to match customer expectations. And the beauty is, ISO's given us a suite of reference print conditions that all share G7 tonality. And this is important because when most people use Adobe Creative Suite to work on their files, if they're looking at their files through Adobe Creative Suite, the native condition, whether you're in Europe or in the US, in Europe it's ISO coded, in the US it's US web coded swap, both of these conditions are natively G7 in nature, which means if I use a reference stake in the ground that's G7 in nature for my output device to match, that means my customer files, the way they saw them in Adobe Creative Suite, will image on my output device and match what they saw very closely on their Adobe Creative Suite. So this is very exciting because it closes the loop between what the customer sees and what you're giving them. So ISO, as I mentioned, has given us 7 reference print conditions, and it's under a new standard called ISO 15339. It's a very exciting standard. And what it gives us the ability to do is be process independent, meaning it works with any print process. And all of these reference profiles are G7 in nature. So it gives us a common stake in the ground for the entire supply chain. So if you're printing on an uncoated stock or on a very coarse brown wood stock, you can still share a visual appearance as if it was printed on a #1 stock, but accurately simulate the effect of that dirty brown groundwood stock and how it's going to affect the images on that substrate. Also note here that when you're using an ICC profile based on ISO 15339, you're doing things that G7 curves alone cannot do. And what G7 curves alone cannot do is they cannot fix the color of the solids or the overprints. And what I often see, if someone tries to G7 with curves a large format device, the reds will go orange and the blues will go purple. And that's not, in my opinion, a shared visual appearance match. It's never mind a colorimetric match. But when you use ICC profiles to do this type of match, now your reds stay red, your blues stay blue. The ISO 15339 also has tolerances for acceptability, which is very nice. And here are 8 different images rendered on the 7 different reference printing conditions based on 15339. And if you start on the far right, you'll see this says CRPC7, and this is the largest reference print condition that's available today. 6 is based on Grackle. So 6 is more of what an offset press can do. So you might be asking, well, why is there a 7? Well, there's a 7 because a lot of digital devices like that Canon Arizona large format printer I showed earlier, that has a gamut that's much greater than Grackle. So why dumb it down to Grackle? Why not take advantage of all the range of color that that device has available to it? So 7 can be used for that. I can tell you I'm also been playing for a couple years now with what I call a beta CRPC 8, which is even bigger than 7, which takes full advantage of all the gamut of the output device, but blues stay blue and those red tomatoes still stay red. Now, as you scan to the left side of this sample, you'll see on the left is a very dirty brown groundwood sample, and you can see that the tonality of the sample is the same. The gray balance is the same, even though the color of the paper is substantially darker. So ISO has given us these reference conditions which allow us to fashion our workflow, whether we're printing on canvas, styrene, silk. We can work our workflow so that we use the given reference condition for our given output. And on the left, we also show an RGB version of what the customer would see with RGB. So getting back to this scenario where you have multiple output devices, if you use the ISO 15339 references as your stake in the ground, you will have a shared visual appearance between all your devices. If you need a colorimetric match, then you would use the same reference print condition, for instance, for the proofer and the sheet fed press. And in this way, you can get a colorimetric match between those. Now, at this point, you might be saying, there's a lot going on. I've got a lot of different output devices. I've got a lot of different substrates. How do I keep track of all of this? And this is where an intelligent color server comes in. And I've been in the industry for many years, and I've seen a lot of color servers come and go. And I've been working with the Alwan ColorHub product for 8 years. And I used to work for a company called Aldus. I used to work for a company called Adobe. I've never had customers so happy with a product as I've had them with Alwan ColorHub. You can look on the online reviews. People don't have anything bad to say about this product because it's like a Swiss Army knife for color conversion. It can take any color space and convert to any color space for both images and brand colors. It's PDF in, PDF out. In fact, it's based on the true PDF engine. In fact, they're a beta site for Adobe. So they've got the latest PDF library. And it allows you to set strategies for your devices based on your device gamut and your reference print condition that you're aiming for. For builds, even though this presentation isn't about branding colors, we're leaving that for a future one. ColorHub can automatically create device-specific builds based on how my HP 360 renders color versus my Canon Arizona versus my HP Indigo. This program plugs into any workflow in a very seamless manner, whether you have a traditional workflow for conventional print or a large format workflow for large format output. And of course, it works with the digital press workflows as well. We also have a 90-day return on investment guarantee, including a payment plan that we can talk about more at the end. So, just to sneak this slide in, this is a new feature in the new ColorHub, which has a color library. It's this dynamic color build capability, so you can plug in your McDonald's red, and based on the output device that you're going to, it will dynamically build the CMYK or even hi-fi generation. If you have extended color gamut available in your output device, so you have more than cyan, magenta, yellow, and black, you have, let's say, an orange, green, and violet, it'll build an intelligent build using the colors necessary to get as close to that McDonald's red as possible. This is how ColorHub looks in a workflow, in that you typically have different cues for different output conditions. Sandy Alexander is one of our huge customers, and if anyone was at the Color Management Conference last year, you heard Sandy Alexander talk about ColorHub being the heart of their workflow. We actually have a write-up on how they're using ColorHub, but they've got 250 cues, and everything through their shop, whether it's a sheet-fed offset, large format, indigo digital press, everything goes through ColorHub. So they've got 250 cues managing their whole operation. It is the heart and soul of their color management, and their color management is some of the best in the industry. Now, you might be asking, okay, I have multiple large format devices and digital presses and multiple substrates. In a typical scenario where I might have 4 different large format devices and I'm printing on 25 different substrates, that's 100 profiles that would have to be built to color manage that scenario. Is that feasible? No, not at all. So we've come up with a way to help define your expectation for a color match based on delta E, and then it'll group the output conditions into profiled groups, so you only need a fraction of the profiles to get done what you need to get done. So here's an actual example with Acuities, Arizonas, Fujis, and Epsons. So there's 25 different conditions for 4 different devices. I set my threshold at a 3 delta E, and this software automatically calculates that at a 3 delta E, it can break it into 13 groups for the 25 conditions. So hey, I've just cut down by 50% the number of profiles I need to make. And then it shows me which profile at the top of each group best represents the other profiles within that group. Now, let's say I change my tolerance to 6. If I loosen my tolerance to 6, now I get 5 groups. So instead of building 25 profiles or 13 profiles, I only have to build 5 profiles. And you know what else? Look over on the right. The top device listed in each group has the smallest standard deviation compared to the other devices in that group. That tells me that's the one I use to profile. And then it tells me which reference print condition best matches that device. So the top one, group number 1, you'll see CRPC 7 is the best profile, reference profile for the Epson. The Acuity on Duroplast, it's CRPC 6, which is Grackle. Group 3, CRPC 4, which is more of a supercalendared condition, is the best one for this. And the Arizona on Rebel, CRPC 3, which is actually an uncoated reference print condition, that again, these are all G7, right? That's the best reference condition for that one. And this is really important because, as most of you understand, to do a proper conversion, you need 2 profiles. The first profile represents the output device's condition, or the representative of the group, and the second profile refers to the reference profile. Now, most customers that I see out there use Grackle for everything, but you can't. If you try to use Grackle as your reference profile for an uncoated print condition, or even a matte or a silk, oftentimes you'll lose details in the highlights and shadows, and you'll never get a G7 passing grade for the print. It's because Grackle is too big to represent an uncoated condition, and that's why we'll want to use something like CRPC 3, which is like a Grackle uncoated reference condition for that scenario. Now, once we have this information, this tells us exactly how to configure ColorHub for each group with correct profiles. So in this scenario, where I have 25 different conditions, I have 5 groups. And I've even listed which printers each group represents. And then I added in red here, the red letters here showing RPC 7653. That's not part of the ColorHub interface. You can go into the queue to see what the configuration is, which we're going to go to in a second. But this shows you the flexibility of how you can set up your queues to not only have shared visual appearances, so queues 1 through 4 have shared visual appearances because they're all based on G7 based ICC profiles. Group number 5 is a colorimetric appearance because I've got my 3HP 360s that are doing overflow work. and I've got them all set up to do this RPC5. So as we go into ColorHub, so that was the Q interface in ColorHub. This is when I go into my task settings. You can see up in the upper left, this is my input configuration, and I have RPC6 for my group number 2, and I'm honoring my embedded profiles that customers might be giving us. And then this is the output section. So you see in the upper left hand corner, it says output. And this is my acuity on styrene, which for group number 2 was the best match for the other devices in this group. So that's the profile that I use for my output. And just to show you down below, I'm using my Dynamic Max Black to maximize my ink savings, so I don't pay the company that's selling me the acuity anymore for ink than I have to. And I'll tell you, I've had companies with one ViewTech printer or one Inca printer save more money in 3 months than what the whole program cost them to purchase. So the ROI on one device due to ink savings on devices like Incas and ViewTechs, less than 90 days. Group number 5 is our colorimetric match with the HP. So the source profile is the RPC5. Down below, you'll notice I turned off my honoring embedded profiles because I don't care what the customer is giving me. I need these to match RPC5. And my output is my HP 360 profile. And so in this way, you'll see my 360A, then I'd have a 360B and a 360C. In this way, with them all pointing to the RPC5 input profile, all 3 HPs will match one another, and I'll get a consistent result. Consistent and accurate result. Now, the number one complaint that we have on ColorHub is not really due to ColorHub. It's due to the output device not printing as expected. The way ColorHub does its color conversions is it looks at the source data, let's say in RPC5, and it looks at the HP data, and it tries to make those match as best as it can. And so ColorHub itself does not shift color. It matches color. If the output device is not printing right, there's typically something wrong with the output device. So we've provided operators with tools that show them that the output device is printing to the right printing aim, i.e. the HP and match mode is printing to, let's say, my RPC5, and my acuity is printing to RPC6. And it tells the operator, as they're doing their production work, that the device is printing right. So here's my workflow again. I've got my ViewTech on the top with my print verifier assessing strips so that the operator knows real time that what's coming off the printer is right, is sellable, and you're not printing work that's going to go right into the garbage because something went wrong in the process. This is where print standardizer and verifier come in. So in summary, ColorHub ties all your color strategies together through an automated, intelligent server. When implemented correctly, it makes color conversions invisible for the operator. And as you saw in my sample, we can do both shared visual appearance matching and colorimetric matching for both images and brand colors. The program works on either a Mac or Windows box, and there's a lot of other capabilities that ColorHub can do above and beyond just this intelligent color handling. Now, to talk about the custom download that we're offering you guys. We're going to provide you a supplied link which has what I'll call a pre-installation survey. And there's different questions based on the type of work you do. So if you're large format, you'll get large format type questions. Digital presses, you'll get digital presses. Conventional, you'll get the conventional questions. You might be multiple, right? You might have all 3, at which point you'll probably ask for all 3 surveys. But in this way, when you fill out your survey and give it back to us, we'll build a custom configuration with the cues already built for what you want to do. And so after you've downloaded the software, you can just restore our preset configuration file custom to your needs, and you can start working with it just by editing your individual cues with your own profiles, and you'll be up and operating with this program in literally minutes. So at this point, I'd like to open it up for questions. I'm sorry I went a little over. Jim, are there questions out there?
Well, you did a great job, Dave. Thanks so much. Yeah, the questions are starting to come in. Feel free to write down any questions that you have, and we can consider them now